we can do it for money problems. Okay, so you guys are going to want to take some notes. So realize that this formula is in the same setup as A times B to the X. Same setup. Sometimes you're going to see this formula, instead of an A, you're going to have a big P, And P, I'm just going to go to the next slide because it's on it, right? This big P stands for the initial value. So this is going to be your bank account. You start with $5,000, you keep it there, you gain some interest. It's going to be the value of your car. It's how much you buy the car for, and then it looks at depreciation. So it is going to be a growth when the item in parentheses 1 plus R is greater than 1. It is going to be a decay when 1 plus R is less than 1. So usually with that rate, it's going to be a minus R instead of a plus R. So we're going to do a couple of each of them. So right now, that's the problem we're starting with. Okay? All right. So we are going to take $1,000 and we're going to invest it at an interest rate of 5.25%. We're going to look at how much money we have after 10 years. So you guys need a calculator. I'm going to go grab some. All right, so if you guys want a calculator, grab a calculator. You are going to need it. Phones away, Ethan. Phones away. Actually, I'm going to open my calculator. I don't think I have it open. Okay, so first thing we have to talk about is we have to talk about that R, right? Right now, I'm giving you 5.25 as a percent. But in the formula, that rate needs to be a decimal. So how do you change 5.25% into a decimal? How do you do that? Anna, what are you doing? You're pointing to the left. Move the decimal 2 places to the left. So that's what you're gonna put in your equation. Okay. All right. So let's set it up. Our P's are initial value. So that's going to be our $1,000. So then we're going to go 1 plus 0.0525, and we're going to raise it to the 10 years. So every time we do one today, right, make sure you guys are following along. If you need me to put it up in the calculator, if you're not getting the same answer, I will, right? But I'd rather just do it in my, actually, I'm going to do this one, right? So I'm going to go to the calculator. I'm going to put it in exactly as that, 1,000 times 1 plus 0.0525 raised to the 10th, right? So the caret underneath the clear button raises it to the 10th power. So let's hit enter. right? You get 1668096. Finn, what are we going to round to? What do you think? It's money. Hundredths. It's money. So 166810. Okay? So that's what we get as an answer. And again, if you guys don't agree with it, make sure you stop me. And again, I'll show you in the calculator. Say it again. Yeah, I round, right? So it's, right, money. So 0.096, you'd round to 10 cents, right? Okay. Nice and easy, right? Nice and easy. All right, so now this question asks, how long to accumulate to $5,000? Theater, where do you think's 5,000 gonna go? Right, if we look at our original equation, where's 5,000 gonna go? PRTY, where's it gonna go? I want $5,000. It would go Y, okay? So I'm gonna get $5,000. I'm still starting with 1,000. I still have 5 1/4, but I don't know how long it takes. So right now, it is totally going to be guess and check at this point, because we need something called logs to be able to solve it. Okay? But we can make an educated guess, right? So let's see. This is 10 years. It wants 5 times the original amount. So you would think, okay, maybe it's 50 years, right? But if I take 5 and multiply it by 1668, do you get that that's way too much for 50 years, right? So if we think 1668, take 5,000 and divide by 1668. 5,000 divide by 1668. So this is an educated guess. Educated guess. What do you get? 3 point something? 2.97. So an educated guess would be 3 times the original amount, right? So an educated guess would be 30 years. So give it a try. Do 1,000 times 1.0525 to the 30. That is an educated guess. I think if I remember the answer, is it a little shy of that, right? It's 4,000 something, right? Let's see what Slade's getting here. 46, right? So 46, 49, it's 4,700. So close, right? So close. So try a number bigger than 30. Try a number bigger than 30, whatever you want. $31, $32, $33, $34. You're supposed to be close to 5,000 because that's what I want. What'd you get, Hannah? 32 was a little over, right? So if you guess 31 years and you guess 32 years, right? What was 32, Hannah? What is 31, 48 something? Okay, and then Hannah, what was 32? 5,141. So you know it's somewhere between 31 and 32 years. So what are you going to guess? 31 and a half, right? So let's guess 31 and a half. So we get 1,000, 1.0525 to the 31.5 years. Again, there's going to be an exact way to do this, but we need this first. So that's pretty close. We get 5,011.83, right? That's pretty close. So I would think the best answer would be right under 31.5 years. Okay. All right. Can we try another one that's going to be a decay, right? Let's try another one that it's a decay. All right. So let's see. You buy a car. And when you drive off the lot, its value is 45,000. Value is 45,000. Let's say the car loses 2% of value per year. What is the value after 5 years? Right? What's the value after 5 years? So we're going to do the same thing. The original amount is 45,000. Instead of adding 2%, this time I'm going to subtract 2%. It loses a value. So then I'm going to raise it to the 0.5. I'm sorry, raising it to the 5. It is always 1. Does anybody know what that 1 stands for? What do you think the 1 stands for? Yeah, Anna, good. It's the whole value that you start with. Ethan, we writing these down? Both Ethans? Sam, you getting this? What did you get? Sam? All right, you got to put this in your calculator. Kaylin, what'd you get? Very good. So the value is 40,676.44. Is everybody okay with that? Okay. All right, let's do the guessing game, right? How long does it take? So how long to half its value? What does that mean? How long to half its value? 50% of the original. So what? 50% of 45,000 is 22,500. 22,500. All right, half of its value. All right, go guess. Go guess. So you can still, right? I use the same formula. I want it to be 22,500. You still use the 45. Again, you're guessing the time right now. You want to get to 22,500. It's going to be a long time. It's like 2% value is ridiculous. It loses more than 2% value a year. You're probably not going to have the car this long. Anybody get anything good? All right, so again, we're doing 45,000, sorry, times 0.98 raised to whatever power. No, it's not going to be a negative. 98 is what 1 minus 0.2 is, right? Think a buck minus 2 cents, right? 98 cents. So what's your first guess? How long it would take to half your value? 30 years? Good guess, right? It's a little more than 30. So Hannah's saying 30, right? I need 22,500. So that's a little more. So maybe I guess 35. Do you guys know this calculator trick, right? If you hit second enter, it gets that last thing up and I can just write over it. So I'll guess 35. 0.98, because look right here, 1 minus 0.2. I just hate putting parentheses in there. Right, so that's pretty close, 22,188, right? So I got 34.4 years. That's what I got. Slade? As the years increase, the value would decrease, okay? All right, think about your calculator a little bit though, right? Someone in D period the other day said, wouldn't it be nice if we had a table to show how the value decreases? You can totally do that, right? So watch, if you do y equals, clear out your equations in your y equals. Everybody should be doing this, right? So I'm starting with 45,000. I'm going 0.98, right? I'm getting 0.98 by going $1 minus 2 cents, right? I just hate doing parentheses. Raised to the x power. It doesn't need to be a t, it can be an x, right? So now we did this the other day. Go to your table, go to second window, start your table at 0 and jump by ones. So second window, start your table at 0, jump by ones. And then you go in second graph. So, right, Slade just said, as the years go up, the value is going down. So I want 22,500, right? So you can keep on moving down until you hit 22,500. Right? And look, it's somewhere between 34 and 35 years. You can get a little more exact, right? I can go second window, right? I can say, okay, instead of changing tables by 1, jump by 0.1, and I can get even closer, right? What am I looking for? 22,500. I should have started at a different number. I'm just going to jump. Hold on. Right? So we're looking for 22,500, right? So look, right there. Best answer would probably be 34.3 years. Why is what? You didn't put the equation in, maybe? Yeah, you don't have t there. Oh, you want it to vary. No, you'd be fine on that. You could say about 34 years, a little more than 34 years. Right? That's fine. Yeah. So let's have you guys try one more of those. One more. So I'm going to give everybody the time to make sure you are doing it. Okay. All right. So we're going to do two parts. Two parts. First part is increasing. Second part is decreasing. All right. So you have 2,500. You have 2,500. You're investing and it's giving you 4%. How much do you have after 10 years? How long will it take you to get, 10,000? So that's the growing part, right? That's the growing part. So then second part, you invest 2,500. It's a loss of 4% on this one. How much do you have after 10 years? So then the second question, how long, I got to change the number, it can't be 10,000, right? So how long to get to 2,000, right? So I want you answering all 4 of those questions. Answer all 4 of those. So the first 2 are an increase. The second 2 are a decrease. Adrian, how about the first one? What'd you get? 3,700? Yeah, 3,700, right? 3,761 cents. Is everybody okay with that one? All right, how about second one? Finn, did you get the second one? 35 years. Okay, so I got 35.3 years. So if you say 30, a little more than 35, a little less than 36, in between 35 and 36, or 35.3, right? By using your table. Anna, how about the third one? Ooh, I didn't get that. Ooh, yes, I did. Hold on, I did the wrong number. Hold on. Yep, 1662.08. Right? Always do 2 decimals. And then Theodore, how about the last one? Anybody get to the last one yet? 5 point what? Again, it's a guess and check at this point. I'm just looking to see if I did it right. I think I did. So do the last one if you didn't get it. 5 point what? I'm getting a little around 5.5 years. Is that okay? We're going to switch the formula up a little bit. Do you guys have a bank account and do you know how it works? You know how it works? What would you say, Ethan? How does it work? You put money in, you take money out, but do they give you anything for shopping at that bank? They give you interest, right? So it's all about how your interest works, right? So like I know my savings in my checking account. And someone asked the other day, well, like it's called a savings account. So shouldn't you get more percentage? Not necessarily, right? Your checking account is usually associated with your debit card. And I know that my checking account gives me more interest than my savings account, okay? It's all about when interest is compounded. So we're going to have a little different formula. Y the same, P1, R, T. They're all the same. But we're going to have this kind of new K there. And usually, thank you. Usually savings accounts, usually compound interest per quarter. So how many months do you think it is if it says per quarter? Three months, right? So per quarter means that it's 3 months, which means per year, it calculates interest 4 times. I know my checking account does it per month. So per month would be 12 times per year. So what that K means is it means number of times per year. Number of times per year. Okay, so you're going to want to write this formula down. R divided by K all to the power of T times K. So that's a different formula. The problems that we just did, we're only getting interest 1 time a year. If banks are giving you interest 1 time a year, shop around because there's other banks that give you interest more times a year. So let's take a problem. We're going to do it for 1 time a year, 4 times a year, 12 times a year, right? And see how it changes. Okay. So we just did this one, right? We just did this one. What is that? Right? So what was our answer to our very first one? Let's see. A very first one was, did I write the answer down? I thought I wrote the answer down. Oh, but that was 5 years, and that one was 10 years. Okay, so let's figure this one out first, right? And then I'll change it. So if you're given 1,000 to invest at 5.25 for 5 years, okay? So our P is 1,000. Our rate is 0.525 again. And right now it's for 5 years. So go figure that out. All right, go figure that amount out. We did 10 years on the other one. Check my number. Do you get that? 1291.55. Again, guys, I want everybody doing this in your calculator. Slade, did you get that? Okay. So now you shop around, right? And maybe another bank says, well, I want you to invest your money with us. So I'm going to give you interest per quarter instead of per year. So that's the new formula. That's going to be y equals p, 1 plus r over k to the kt. So I'm going to have $1,000. I'm going to have 1 plus. My rate is 0.025. I'm going to divide it by 4. That's my k. And I'm going to raise it to the k times 5. So Ethan D, how much more? Hopefully you would think you'd get more money. How much more money do you think you're going to get? 1291.55 is when they only give you interest one time per year in December. So now instead of December, they're going to give it to you in March, in June, whatever the 9th month is. What's that? August, September, and then December. A lot more? Do you think double? Probably more than that. All right, figure it out, guys. Figure it out. 4 times? I want to go to that bank. I think you'll be surprised. Do it out. I think you'll be surprised. I think you'll be surprised. Is that what you guys got? $6 more. Well, why is like Theodore and Ethan saying like 4 times more? I totally get why you're saying 4 times more, right? Because it's by quarter. But what is being increased? What is being decreased? What's being increased, Slade? R is not being increased. R is actually being decreased, right? Because look at what R is. This percentage rate right here is 0.0525. So now we're taking that 0.025 and dividing it by 4. So let's see what that is. 0.0525 divided by 4. So instead of getting 5 1/4 interest, we're getting 1.31%. So our interest rate is being cut by 1/4. Anna? Yeah. Right? Our interest rate is being cut because it's only getting it every 4 times a year. But look at what's increasing. The number of times you compound something is increasing. So you got to realize, yeah, I'm going to get more money, but it's not going to be that much more, right? It's not going to be that much more. What? Yeah, they're just giving you the interest, but that's good because it compounds, right? They're giving you money in March, and then you're getting a little more interest in June and a little more interest in August, right? Okay, so you guys try another one. Let's say K is 12, so that's my checking account. If I'm investing $1,000 at 0.525, but I'm compounding it 12 times a year, I'm going 12 times 5. Guys, can you please? What is this? All right, so calculate that, please. Yeah, and hopefully you're going to think you should be somewhere around that 1297. 1297. It looks like you're done. What'd you get? Yep, 1299.43. So you're doing it by year. You're doing it by quarter. You get a little more money. You're doing it by monthly. You're getting yet a little more money. Did you not get that? Okay. So this is how I would type it in, right? I would do this. Again, I hate parentheses, but it's not like you can't really help it this time. So I would do the inside first. I would do inside the parenthesis first, right? And then I get a decimal. Right there, 1 plus, 1 plus, right? So then you have to raise it to the power first. So I would raise it to the 12 times 5. And then I multiply by 1,000. So I like to do it piecemeal. You can do it all together, but you just need to make sure you have parentheses. So you need to go 1 plus 0.0525 divided by 12, close 2 parentheses, raise it to the 5 times 12. Right here, K times T. K times T. You can do it all in one. I don't like to do it in one. This is me. This is what I would do. This is all in one. Same answer. I hate putting parentheses in. That's why I don't do it all in one. Okay. All right. We're going to try one more. I'm going to give different sections, different amounts to do. All right. I don't think I have it on my next one. No, I'm going to make it up. All right. So let's say when you're born, right? Let's say when you're born, someone puts in $5,000 for you in an account. $5,000. They find something that gives you interest. Let's use kind of a high amount. I don't know, 15%. Kind of ridiculous to have 15%. Okay. So I am going to figure out for one compound. I want people by the window to figure out a compound quarterly. I want people in the middle to do a compound monthly. And then I want people by the whiteboard to compound daily. 365. Okay, so window, you guys are 4. Middle, you're 12. Whiteboard, you're 365. Oh, I got to tell you how many years. Sorry. For 18 years until you become an adult. 18 years. Check with each other. See if you agree with it. So that's me. Nobody's going to match me. 15%, 0.15. 0.15. So however many years, 18 years times 12. Yep. All right, so window people, what'd you guys get? Did it start with a 6 or a 7? What did it start with? 0.10, very good. All right. Right, so because we're investing a lot more, the gap is going to be bigger, right? How about middle people? What did you guys get? I'm going to guess that it starts with a 7. What did you guys get in the middle?
I didn't get a 7.
9-1. Yeah. Yep. Okay. And how about whiteboard? What did you guys get? 4-1. Yep. 0.41. So does anybody not match with those and you want to see it in your calculator? Okay. So if I do the 12 one, right? So I am investing 5,000. I'm going 1 plus, open a parenthesis, what I say, 15%. And you guys were monthly, so divide by 12, close 2 of them, raise it to the 12 times 18. So I think I'm okay. 73,163. Did you just really say it's the parentheses? Right? That's why I hate putting all the parentheses in. So I would do it like this. I'd go 1 plus 0.15 divided by 12. That gets me the inside. Raise it to the 12 times 18. And then multiply by the 5,000. I hate putting parentheses, and I always forget one. Okay? Is that okay? All right, I'm going to show you one more formula. And it's going to be off of this one. Okay? One more formula. Oh, right there. And it's called compounding continuous. I'm going to put it on here. All right, so something that's called compound continuously. So what that means, right? You put this $5,000 in the bank. You set up a scenario on a computer to just automatically keep on giving you money. It calculates it. As soon as it's done, it does it again. As soon as it's done, it does it again, and so forth. So this is called the compound continuous formula. So same the Y, same P. Then it's got this E, same R to the T. So E is a specific number. So I'm going to take that 5,000 that I'm investing. I'm going to take the number E, which I'll show you on your calculator, 15% for 18 years. So I'm going to go to the calculator. Yeah, I'm going to show you where E is. So you're going to go 5,000 times E. There's 2 spots that you can find E. If you look above the division, there's a little E in blue. But the one that I like is the one right above LN. And the reason I like that one is because it automatically, so it's red on my calculator now, right? It automatically puts the caret in there for you. So that's just why I like that one. 0.15 times 18. And all you got to do is hit enter. And look how close your answer is to the daily, right? your answer is so close to the daily. Because again, like $40 when you're doing it for 18 years isn't a huge difference. Do you think banks would calculate anything continuously? They don't. Do you think banks calculate stuff daily? What do you think they actually do? What do you think they calculate daily? Probably what? So when is it going to be their money? So when you take out a loan, right? So if you guys go do a car loan and you call them up on a Monday and say, you know what, I just won something on a scratch ticket, I want to pay my car loan off, right? They're going to say, okay, if you come today, you owe us $5,000. You're like, oh, I'm working for the rest of the week, I can't come in until Saturday morning. They're like, okay, Saturday morning, you owe me $5,005 because you got to pay that interest for the rest of the week. Okay? All right, so that's all I got for you. And I told you guys I would give you time to do your homework, right? So we don't see each other on Monday, but this first sheet, back and front, the only one that you need for the K is number 4. So if you put number 4, if you put a little K next to it, bye, have a good weekend, Hadley. If you put a little K